Hey everyone, my name is Anvita Bansal, and today we are going to discuss a problem based on arrays. The question that we are going to discuss is, let's move to that problem. Sort an array of zeros, ones, and twos. So you're given an array of size n which contains only three values, which is 0, 1, and 2. There can be any number of values in that array, any number of zeros, ones, and twos, and you need to sort the array in ascending order, right? So what is the catch here in this question? This is very easy. If actually also, and even if you use brute force, what you can do, you can simply sort an array. If you use an inbuilt sorting function, then it takes n log n of time and you can sort the array, and that's how you can sort this also. But the problem's demand here is that you cannot use the sorting method, the inbuilt sorting method. So what can you do such that you can sort this array of zeros, ones, and twos without using any sorting inbuilt sorting method? This is what we are going to discuss today in this problem. So I hope you all can see my screen. Let me. Fine. Okay. So before we start discussing, let's move to the whiteboard and understand that what you're given here is you're given an array. It contains 0, 1, 2, right? Now let's take one test case such that you have 1, 0, 1, 1, 2, 0, 0, 1. Let's say this is one array that we are given. It only has zeros, ones, and twos. How can you sort it? See, brute force approaches can be like, first thing what you can do is, what can come to your mind is, you can keep a count variable, count three different counts for zeros, ones, and twos, and then once you know how many zeros are there, you can simply place them in an array, right? But that is not an efficient method. Second thing, you need to do this in place. We don't want to use an extra space here, right? You create another array, then keep a counter variable for each of these zeros, ones, and twos. You have the count, then you can definitely easily place the values in a new array that you are going to create. But we want to do this thing in place. So how can we do it? So I'll just write an algorithm's name here. You must have heard about this earlier also. Dutch National Flag Algorithm. Dutch National Flag Algorithm. So, what is this algorithm? Actually, this is a very direct question. This is the direct application of this particular algorithm. Sometimes they just very easily twist the question by saying that you are given three different colors and you want to sort them in this order. And so the values are like this only, 0, 1s, and 2s. Now, what do we do in this algorithm is actually the solution for this problem in such a way we can sort this in place. See, if you have a look here, let's keep a variable. Let us take it as, let me, left variable, low variable, whatsoever you want to name. Let's take it left, right? There's a left variable I have taken which points at 0th index, right? Okay. Then I have a variable which, let's say, I am pointing to the last value present in the array, that is n minus 1th index left. Then let's take it right index. Okay. Now let's just try to understand. We have two variables, we have two counters here we have taken. Can we do something such that we can swap the values and we can sort the array using these two variables? Can we do something like that? See, we have left, we have right, we have, at both the places we have one. Actually, what do we want in the resultant array? It should be something like this. We have three zeros, then we have 1, 2, 3, 4 ones, and then we have only 1, 2. So we want the resultant array to be in this form. What can I do is, here in this problem, let's take three variables. I'm taking three variables. Left, I have already pointed to 0th index. Right one, I have pointed to the last index, n minus 1th index. And then I am taking a, let's say, mid variable, which I am again pointing at 0th index. Left and mid both are at 0th index. Now, what is my logic here? What I'm trying to do is, at every step, I am just assume like this, that till left, right? Left is your window. Let's assume that this is one window where left is pointing. Right now, left is pointing at 0th index. So we are assuming that we are solving this problem in such a way all the values still left are already sorted. They already contain zeros till left index. That is my assumption, that the logic or the theory that I'm creating in which we can solve this problem. Not I'm creating, this is the actually theory of Dutch national flag algorithm. What that you are using three variables here, okay, and then how do we solve it? Let's try to iterate over this array and understand if we can solve this. Fine. So my assumption is till left index, all the values are already in sorted order in such a way that till left index, the values should be zero. All the zeros should be placed before left. Right now, what do you see here? It is 1, right? And value at mid is 1. So what you are going to do, you don't do anything and just increment the count of 1 mid by 1. Now your mid is placed at this index which contains 0. Whenever it is 0, you will swap with the value present at left index. Left is pointing to 1. Okay, once you swap it, let me write it here, proper test case. Let's have a look. 1 0 1 1 2 0 0 1. Okay, so what am I doing is, my left was here, now my mid is here, and my right is already here. Okay, whenever, if, I'll write the pseudocode later on, let's understand the iteration first. Now my mid is pointing to 0, so what I'm going to do, I swap it with the value present at left. Okay, so once I swap it, my array becomes like this: 1 1 2 0 0 1. Right, this is the after iterating, this is how it looks like. And what happens, my left, which was at this index, after swapping, I will increment my left with 1, means L plus plus, and then my mid should also be incremented by 1, and my mid now is present at this index. So see, our theory was, what we wanted to assume was that all the values till left index should be 0. That is my assumption. So we have already done in one iteration, we can see the value before left is 0. Okay, whenever your mid is 1, you do nothing, just simply increment the count of 1. Again it is 1, do nothing and increment the count of 1. Your right is still at this position. Now when your mid is pointing to a value which is 2, what you're going to do is swap it with right. Swap it with right. The assumption that you're making with left considering zeros, do the same for the rights considering 2. That means all the values to the right pointer, to the right of the right pointer, should be 2. That's my assumption. Okay, so once you swap it with right, your array looks something like this: 0 1 1 1. 2 will be swapped with 1, so here we'll get 1 0 0 2. Right, and then what will happen, just decrement the count of your right pointer. Your right will point here, and your mid was at which position? Mid was at this position after swapping, which became 1, and you don't do anything here with mid. Why? You will understand in the iteration. So your right pointer is at 0, your mid pointer is at 1, your left pointer is at 1. Okay, fine. So when you see, now you again do the search, you again do comparison. Your mid is pointing to 1, you do nothing, just increment the count of mid by 1. So when you are at this position, you see you get a value 0. Whenever you get a value 0, swap it with the left pointer. Okay, because this is what you want, this is how we are handling left pointer. Now once you swap it with left, the array that you will get in this iteration would be something like this: 0 0 1 1 1, and this one will be swapped with this 0 1 0 and 2. Right, so once you are done with the swapping, you will also increment the count of mid. Now after this swap, after the swapping thing, you have already incremented the count of mid. Now your mid is pointing to 0, and your, by default, your right pointer was also at 0. That doesn't matter. What you need to check is where your mid pointer is. That's how you're making comparisons. So your mid pointer is at this position right now. What is it? It is 0. Also, once you had swapped this value with this left pointer's value, you also incremented left, right? So your left is at this position now. Ideally, this is your left, this is your mid, and this is also your right. Now when you encounter a 0, you always swap it with the value present at left pointer, so this will become 0 and this will become 1. And now if you see, your entire array is sorted like this: 0 0 0 1 1 1 and 2, right? Now what did you understand from this? From this iteration, what did you get? See, this is about this algorithm, that you are maintaining three pointers here, okay? Three variables, three pointers, in which you are making comparisons with a third pointer. Let's say you have taken mid. So till how long you are carrying over this mid to the length of your array, means how many times are you making these comparisons? You are making these comparisons, or you are running this loop only till your mid index is less than or equal to your right index. Once your mid index crosses the right index, there is no point of comparison, because by that time we have already iterated our array and made the necessary comparisons and the swapping that were required. So this loop should be run for these many times until your mid is less or equal to your right pointer. Okay, let me write a pseudo code here, then you will understand it better what we do. Okay, one second, let me check if you fine. I just want to know if you can write in comments if everybody could see my screen properly and you have understood the iteration till now. I'll write the pseudocode hereby. Okay, so there is a problem. Can you please dry run 2120? Let's take this example also before I go on to pseudocode 2120. Okay, have a look here then. Let me, okay. Let's try to run this over 2120. And meanwhile, you guys also try it on your own. So what things we take? We are taking three variables, left or whatsoever. It can be anything of your name, left, mid, and right. I'm taking. How am I maintaining it? Right now, my left is at 0. Then these are the indices that I'm writing: 0, 1, 2, 3. My left is here, my mid is here, and my right is here. Okay. So if my ARR of mid is equal to 0, then what you are doing? You are swap what ARR of mid with what? With ARR of left pointer, right? Okay. Then once you are done with the swapping, you also increment your mid counter and you increment your left counter. Then if another case, second case, your ARR of mid is your 1. See, you don't want to do any swapping when it is 1. You just simply increment the count of mid, right? And when you have the third case, that is when your ARR of mid is 2, so you don't need to write that condition because that's very obvious. What do? You swap the value with the right pointer. Swap it with right pointer. And after this swapping, you do simply decrement the count of your right pointer. That's what you do. Now this is your pseudocode also. And since you have understood this, you can easily run over this test case. Let's do it on our own. Okay. So what is this case? This is a third case here. Come at this case, at else case. If your ARR also, this will fall under the loop till your mid is less than or equal to R, right? So mid is 0, R is 3, it is less. Okay, then you come at third condition. What do? Because ARR of mid is 2, so you swap it with right's value. What is that right? It is 0. So this will become 2, this will become 2, and this will become 0. So your array comes, have a look here, your array will look like this: 0, 1, 2, 2. Okay. Okay, then what do? You simply decrement the count of your right pointer. Your right was at third index, now your right will be here, and your left was here only. Your left will stay there and your mid will also stay there. Okay, fine. Now what? One second, let me check. Left, mid, and then right. You did the swapping, your right came here. Fine. Now check, your M is again less than your right pointer, and both are left and mid are still pointing to your 0th index. Okay, fine. Now, if your ARR of mid is 0, which is the case here, what do? You swap it with the left pointer. So here both are pointing to the same position. So swapping will make no difference. And then you increment the count of both left and mid pointer. So eventually left and mid will point to your first index. Now what is this case? This is the second case. Now when your loop comes here, your mid is at first index, your right is at second index, it is still less than your right index, then you check for the condition, it is 1. In case of 1, you do nothing, you simply increment the count of 1 mid. Now your mid and right are at the same position, and you can put this equal also, and even if not, it should run. So it is at this position now. And what is the value? The value is 2. So even if you swap, it will make no difference, right? To avoid unnecessary swapping, like the case when M is reaching till the position of R, you can remove this equal sign also. And then swapping will give you nothing, and right pointer will come at this index. Now mid is at this index, 0 at right is at first index, mid is at second index. Now when you check for the while loop condition, M is less than or equal to R, it will fail. So basically you have run all the iterations that were possible with this condition, and you come out of the loop, and your array, if you see, is already in the sorted order with these iterations. Is that clear to you? And this is actually the entire code which we have to write now, and that is the explanation part. Also, what we have done, we have solved this problem in exactly one pass. The maximum number of comparisons when we do, it will be in the worst case, it will check for each and every value present in the array, right? It will go and check for the comparisons, and in such a way that it iterates over the entire array. Okay, so in worst case, the time complexity will be of O(n), that is n is the number of elements in your array. Is that okay? So I think we can move to the code and try to pass it. Fine. Yes, we can count it too. I already started with this approach when I started this today's live. But the only problem is using those counter. How do you do that in place? That is the point here. That is why we use this approach. Fine. So let's take the variables int left and left, left, right, mid equals 0, and right equals to n minus 1. This is how I am positioning my pointers. Now let's take a loop while your mid pointer is less than or equal to your right pointer. Okay, to check for the conditions. If ARR of mid is equals to 0, you swap it with the value present at your left index. So for swapping, we use our third variable. Let's take int temp. That's what we are going to do here. In temp, store your ARR of left, ARR of left equal ARR of mid, this way. Okay, then ARR of mid equals temp. Is that fine? Okay. Then once you are done with the swapping part, you increment the count of left and you increment the count of your mid index. Okay. This is your first condition. Then if your ARR of mid is 1, you do nothing, you just increment the count of mid. Fine. In else part, that will handle your condition when ARR of mid is 2. What do? You swap it with ARR of right. So how do we do? We do it similar way we did above. In temp equals ARR of right, then ARR of right equals ARR of mid. ARR of mid equals temp. That's what we are doing here. And then decrement the count of your right pointer. Is that fine? Else part, while loop ends here, and then nothing, just even if you don't return, your array would have been sorted in place. Let's try. I think this A will give me error. Let me- Right. And what else? Temp equals. Hmm. Let's submit it. Fine. So this is about this problem. This was very easy. The only thing is, once you are up with this algorithm, you understand that we can use 3 pointers, this kind of approach, then you can solve better problems. Try to solve it yourself. One better one. You are given an array of zeros, ones, twos, and threes. Okay. So how can you sort it in place? Try to sort this array containing 0, 1, 2, 3. It can be in any order: 0, 0, 1, 2, 3, 1, 0, 2, 2, whatsoever. Right? So here it was sort 0, 1s, and 2s. Here it is 0, 1s, 2s, and 3s. So try to do it on your own. Try to think about this problem, and obviously take hint from what we take hint from the approach that we use today, and try this on your own. Then if you don't get it, we can discuss in our next lecture. So if you have any doubt, you can ask me. Otherwise, this is about today's lecture. Thank you then. Thank you everyone. See you all in the next live. Bye.